Welcome back to Chapter 1, Part 7, Picturing Distributions with Graphs. We just got through working with categorical or qualitative data. Now we're going to work with quantitative data. Organizing quantitative data. The popular displays for quantitative data are either the frequency tables, which is usually the first thing that you have to do. So you organize discrete data in tables and in histograms. You can also organize continuous data in tables and histograms. You can draw stem and leaf plots. You can identify the shape of the distributions and draw also time series plots. And there are more different ways to represent continuous data, such as dot plots, normal probability plots, other type of plots. But these are the ones we'll concentrate in Chapter 1. Now again, raw quantitative data comes as a list of numeric values. Each value is a count or a measurement. Counts meaning discrete, and measurement meaning continuous. Comparisons, one value being more than or less than another, can be performed on the data value, and mathematical operations, addition, subtraction, multiplication, etc., can be performed on the data values. So let's look at the first type of quantitative data, discrete quantitative data. What you'll see is it's got some similarities between the categorical or qualitative data, and it will bridge us into doing things with continuous data. So it's somewhere in between the two. Discrete quantitative data can be presented in tables and bar graphs in several of the same ways that we saw with our categorical data. You're going to list the values in a table, use the discrete value instead of a category name. List the frequencies or relative frequencies. Now the histogram, it's the bar graph for discrete data. What you see with the bar graphs is that the bar had space that separated each of the bars, but when we deal with discrete numbers, the bars will touch one another, and that's when we call it a histogram. Use those discrete values for each of the categories of our discrete value instead of the category name, and arrange the values in ascending order. Unlike a bar graph, as I said before, there won't be a space in between the bars. They'll touch one another. That's why we call it a histogram. So we're going to go over an example. This is the Wendy's example, and this is how the problem goes. For 40 days, Wendy's looks between the hours of 12 and 12:30 how many customers go through their drive-through window. So let's say on day 1, from 12 to 12:30, they saw 4 customers. On the next day, they saw 7. On the next day, they saw 3, and so forth. And they did this up to 40 days. What we're going to do is what we see on the worksheet part of our mini-tab is on day 1, they saw 1 customer. On day 2, they saw 2. Now, I took the data and put it in, I sorted it. So I could see. So really on day 1 it might not have been 1 customer. It might have been this one right here, 5 customers. But I put my data, I sorted it from smallest to largest. But so how can I find out how many times we saw just 1 customer, how many times we saw 2 customers, how many times we saw 3, is we do our tally command. We can do counts and percents. So there we see, we saw 1 customer 1 time, we saw 2 customers 2 times, and so forth. So we get a nice chart there, and we have some information. And we can see that 11 out of the 40 days we saw 6 customers. Now this is good information for someone that's a manager of that Wendy's, because they'll know how many people they should have serving that window from the hours from 12 to 12:30. They'll probably need to serve about 6 or 7, between 5 and 7 customers comfortably, and that would make everybody happy. That way I'm not paying a lot of employees just to stand around, and I'm also not angering customers by making them wait because I don't have enough help. So that's why this is a good analysis to do. So I put this, it's on your slide, and there's that, what I just did, the tallies command, and I've got these counts and percentages. So we can ask these questions. What's the most frequently occurring number of customers? Well, that's easy to see. It's 6. What percentage of the intervals have less than 3? Well, 15% plus 2.5%. So altogether, 17.5% had fewer than 3 customers. So to get that 17.5, we wanted fewer than 3 customers. That means 2 or 1 customers. So I just added up the percent of 2 customers, which is 15, and added that to having the percent of the time seeing 1 customer, which was 2.5. That gave me the 17.5. What proportion had 9 customers? Well, the proportion would be 2 out of 40, or 1 in 20. Now, I'm going to leave it at 2 out of 40 because in statistics, a lot of times we don't want to reduce the fraction. So I'm just going to leave it at 2 out of 40. If you did 1 out of 20, you would not be wrong. But I'd like to keep the number that was in our particular sample. Now, how many had between 4 and 8 customers? That means I have to add 4 plus 7 plus 11 plus 5 plus 8. Because when we say how many between, we're talking about inclusive. So 29 of the customers, 29 times we saw between 4 and 8 customers. Now let's go and make our histogram for the Wendy's example. I'm going to go into graph. We want a histogram. Simple. What you do is you go into this graph variable, you touch it, then you have to select, since there's only 1 column, it's the only one we can select, let it go in there. Now I can do stuff in here, but I'm just going to hit OK, and this is the default graph. But there's some problems with this default graph in Minitab. I don't like where the marks are. It should be at 1, 2, 3, 4, 5, all the way to 11. Where I have my tick marks are actually 0 because there could potentially be 0 customers. So I need to change that. How do I do that? I put my arrow right there, almost near touching that y-axis, and I left click. And what I can do for that is I can say, hey, I want to change the binning. I want my tick mark to be in the middle of the bar. That's right. But my number of intervals has to be 12 because I want from 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, 9 to 10, 10 to 11. So I want to see them at every tick mark, so I need to change that too. Oops, wrong thing. So I want to see a tick mark at each of these. So I say, where do I want the position of the tick marks? At 0, at 1, at 2, then also at 3, and so forth. So you're going to do this for each of the numbers. Once I have it for each of them, I hit OK, and now I have a tick mark at each one of them. And I could also have it here so I can see 1, 2, 3, 4, and 5. It wouldn't be too crowded to do that. So the position of the tick marks, I'm just going to add 1 and 3 and so forth to that. I hit OK, and then this is what I've got. Now, another little nice feature that I didn't show before is you can actually make it easier for the reader when they're looking at your graph. And I right-clicked, and I want to add grid lines. If I add these grid lines, it makes it much easier for people to see. So I'm going to do it on the major tick marks for the y-axis. And so someone could read, oh, we saw 2 customers 6 times. So that's just a nice added thing. And let's go on and change our titles in here. So I'm going to go double-click and change some of these titles. So you could do something like this and make a pretty nice graph. So let's go back to our PowerPoint and see our example. So there's one with the frequency and one with the relative frequency for our Wendy's arrival. And we can ask all kinds of questions about that, just like we did with this frequency table. Now we're going to stop with our discrete data, and in our next part we're going to go into continuous data. So see you in